We're going to continue talking about solving inequalities, but first we're going to take a little sidestep and talk about absolute value. Absolute value, as you recall, is a number's distance from 0. So the absolute value of 2, how many spaces is 2 from the origin? Is 2 spaces. How far is negative 2 from the origin? Also 2 spaces. Absolute value is always positive. So you may recall that from an earlier chapter. Now we're going to solve some absolute value equations today. What's the value of x that makes the statement true? For what values of x, what can I replace x with? Well, most of you will tell me that x is equal to 8. But is that the only number that makes that true? If you think about it, the absolute value of negative 8 is also 8. So there are two possible solutions, the plus or minus of 8. And it can be written with that notation. Let's look at a second example. What can I replace x with to make a true statement here? Again, think about it and we'll discuss your answer. Now let's talk about solving some one-step and perhaps two-step absolute value equations. The first thing you want to do is make sure that the absolute value expression is isolated. If it's already isolated, then you're going to solve twice, because remember, what fits inside that absolute value symbol could be a positive or a negative. And that's what we refer to as writing an equivalent linear pair. So we take our first problem here, and again we'll solve twice. We're going to solve x plus 2 is equal to 7, because what fits in here could be 7. And we'll also solve x plus 2. We'll keep that expression, and this time we'll make it equal to negative 7, because again, the absolute value of 7 will be 7, and the absolute value of negative 7 also 7. Solve twice. I get x is equal to 5. Solve again by subtracting 2 on both sides. X is equal to negative 9. Let's check that to be sure. Well, 5 plus 2 is 7, and the absolute value of 7 is 7. So the first one works. In the second one, I have negative 9 plus 2. Well, negative 9 plus 2 is negative 7. And once again, the absolute value of 7 is negative 7 is 7. So it works. Looking at a second problem, we're going to solve twice. We're going to get x minus 3 equals 9. And again, we're going to keep that expression. X minus 3 will equal a negative 9. One inverse operation to isolate our variable. X could be equal to 12. And x could be equal to negative 6. Well, 12 minus 3 is 9, and the absolute value of 9, once again, 9. Then I take negative 6 minus 3. Let's do that check. Add the opposite. Well, negative 6 plus negative 3 will give me negative 9, and the absolute value of negative 9 is also 9. So these are the two possible values to make this absolute value equation a true statement. Let's look at a couple more. I'm going to look at x plus 3 is equal to 8. And again, solving twice. X plus 3 equals negative 8. Subtract 3. X could be equal to 5. Subtract 3 on the other equation. X could be equal to negative 11. And again, you can do a quick mental math check on those. Each problem a little bit different than the previous. 3x is equal to 15. Solving twice, 3x is equal to negative 15. Divide. X could be equal to 5. Divide by 3 again. X could be equal to negative 5. 5 times 3 is 15. 5 times negative 5 times 3 is also negative 15, which is absolute value 15. Now, I did mention that sometimes you have to be sure that your absolute value expression is isolated. And here's an example where it's not. And I highlighted the absolute value symbol, and you're noticing that there's something being subtracted from the absolute value expression. So the first thing we need to do is add 5 to both sides. Because again, our goal was to isolate the absolute value symbol. Now that I've isolated it, I can write those two equivalent equations. Solving twice, x plus 1 is equal to negative 20. Let's subtract 1 on both sides. One possible solution, x could be 19. Subtract again, x could be equal to a negative 21. And again, replace it and check. On to my next one. Again, I see an absolute value expression, and I see something on the outside. 2 is multiplied by that expression, so I have to isolate by dividing by 2. Now that I have it isolated, I can go ahead and write those two equations. X minus 2 equals 6, and x minus 2 equals a negative 6. Add 2. X is equal to 8. Add 2. X is equal to negative 4. Let's just try one or two more, and then we'll give you some time to practice on your own. Try this one, and then we'll also try one other. On the left, we're going to divide again by 2 to isolate the expression. X minus 2 is equal to 5. Dividing both sides, it cancels on the left, and 10 divided by 2 is 5. Time to write those two equations, once with 5 and once with a negative 5. Let's add 2. X is equal to 7. Add 2 again. X is equal to negative 3. If we don't isolate the absolute value expression first, we're not going to get the right answer. Let's multiply by 2 on both sides. And we're going to get 2x minus 1 is equal to 18. And then we'll get the two equations. We'll start by adding 1. 2x is equal to 19, and we'll divide by 2. We don't have to rewrite this into a mixed number. We can leave it like this. And we can get fractions from time to time. Let's add 1 to both sides. I just wanted you to see it's not always an integer. Negative 17, and divide by 2. X is equal to a negative 17 halves. And we'll stop at this point and give you an opportunity to practice some on your own.